We're looking at lesson 6 in our atomic theory and bonding unit. We're going to be talking about Lewis structures today, okay, which we're going to be talking about how we draw out these structures. So it's going to be a little bit of a different mind shift from what we've been talking about the other days. So looking here, we need to review just the difference between ionic and covalent bondings here quickly. So ionic is going to be the transfer of electrons between atoms, form ions that form giant ionic lattices. So what's important is you see the cation now lost an electron, the anion has gained one. Covalent is the sharing of electrons between atoms, okay? So what you're going to see is the overlap of two atoms and they're sharing a bond. So as we talk about the Lewis structures today, we're talking exclusively about covalent bonds. Ionic bonds do not have these Lewis structures represented. All right, so Lewis structures, again, it has to be covalent bond bound molecules only. They use dots to represent all electrons. Okay, so we're going to be drawing these things out. It has to do with valence electrons. So we talked about these earlier in the year, but valence electrons are basically how many electrons it has in the outermost shell. So what you need to do is you need to, first of all, count the total number of valence shell electrons. Okay, now what we need to make sure we have on our periodic table is kind of a cheat sheet go-to of how many valence electrons we have for the different columns in the periodic table. So, all right, so make sure you have above these particular columns. So groups with H at the top, group with beryllium at the top. We're going to skip all of the transition metals, so the S, C, Ti, and so forth. We're going to go over to the group, I'll leave some dots there, of B at the top, carbon at the top, N, O, F, and He. So you need to make sure you have the number of valence electrons that they have. So I'll write valence electrons. So 1, 2, then 3, 4, 5, 6, 7, 8. So if you've ever heard anything about the octet rule before, the goal is for them to have 8 valence electrons. So helium's column already has 8. So based off of that, you can use this idea of how many bonds it wants. How many covalent bonds, okay? So hydrogen, because hydrogen can only reach the S2, this is different kind of than thinking about just 7 or 8 minus 1. Instead, because hydrogen can only have 2 in the outermost shell because of the orbital of the S, anything in hydrogen's group wants to have 1. Beryllium's column you won't really see in ionic compounds or in covalent compounds, so that one you can kind of ignore right now, okay? Boron, in theory, if you saw anything from that group, you'd want to have 5. You'd have 4 for carbon's group, 3, 2, 1, and 0. So that means you won't see anything in the noble gas column because they don't want to make any bonds, okay? All right, so then what you need to do is you need to decide in a species that has more than 2 atoms, you decide which atom is the central one, okay? So this would be the one that needs the most bonds, basically. You're going to arrange the remaining electrons to complete octets of things on the outside. The central atom lacks an octet, you need to form multiple bonds, and so forth. And a bonding pair of electrons represents a covalent bond, and it's represented with 1, okay? So we're going to be using dots to represent electrons. Whenever we draw a line, think about basically having 2 dots connected, okay? That's showing you that you've got a bond connecting 2 dots. And one thing that's important is that the thing in the middle, okay, so our central atom can have more than 8 electrons, is what is kind of weird to wrap your mind around, but as we draw these, it'll make more sense. So first thing we need to do, let's just start practicing. So we have fluorine here. First thing you need to do is ask yourself, okay, how many valence electrons does fluorine have? So we look back at our cheat sheet here. Fluorine has 7. So there's 7, and there's 2 fluorines. So we total 14 valence electrons. We only have 2 atoms, so we don't have to worry about this whole what goes in the middle thing. Okay, so I'm just going to write 2 F's to show the 2 fluorines. Now we think about each fluorine wants to make 1 bond, so I'm going to draw 1 line in between them. Okay. All right, so now I've got 2 electrons represented, because think about basically a dot on either end. I need to draw 12 more electrons. The goal is for every element, or atom in this case, to have 8 electrons surrounding it. So there's 2 electrons in the bond. So that means each fluorine needs to have 6 more dots to have a total of 8. So 2, 4, 6, and 2 in the bond is 8. So 2, 4, 6, and then the bond again is 8. So if I count them all up, 2, 4, 6, 8, 10, 12, 14. Okay, so that's the total number we need, so that's good to go. All right, the next one here, we've got oxygen. So 2 O's. you can count these up too, sorry. So oxygen has 6 valence electrons, so 6 plus 6. So 2 O's written down here. We think how many bonds does each oxygen want to have? Well, it wants to have 2. So what we're going to do is put a double line here to show 2 bonds. And then each oxygen wants to have 8 total electrons around it. Each one has 4 in the bond already. So it needs 4 more dots. So 2, 4, 6, 8, 10, 12. Same number we need to have. All right, let's look at the next one here. So NH4 plus 1. If we start adding them up, this is for something that has different elements making up the compound here. So we've got N has 5. We've got 4 hydrogens. Each one has a valence electron of 1. And then if it's plus, remember you subtract 1. Okay, so it's kind of opposite. So we've got 5 plus 4 minus 1, total of 8. Okay, so now you have to decide which one goes in the middle, N or H. So you ask yourself, okay, which one needs more bonds? So H only needs 1, N needs 3. So the N's going to go in the middle. You're going to write 1 N, 3 surrounding. Okay, and then you ask yourself, how many bonds does each H want to have? Each H wants to have 1, so 1 line next to each H. And we count where we are so far. So 2, 4, 6, 8. Hope that's the number we need, so we're good to go. All right, so there's plenty more examples that you can keep practicing with. We can do one more together here. So I'm just going to pick PF5. All right, so if you look at the periodic table, which hopefully again you have in front of you, phosphorus is in the same column as nitrogen. Okay, so if you look at this cheat sheet, everything in the column of nitrogen has 5 valence electrons. Okay, so that's what we have right now. So phosphorus has 5. We have 5 fluorines. Each of those has 7. So we have 5 plus 35 is total 4. So we ask ourselves, okay, which one goes in the middle, P or F? Again, P is in the same column as nitrogen, so phosphorus wants to have 3 bonds, fluorine only wants to have 1. So that means that phosphorus goes in the middle because it wants more bonds. Write the 5 F's around it, or where. Okay, then we need to decide, okay, how many bonds does the thing on the outside want to have? So fluorine, you look back at the table, wants to have 1 bond, so we draw 1 line next to each fluorine. So far we have 2, 4, 6, 8, 10. We need to have 40 electrons, we need a lot more. So then we need to make sure everything on the outside has 8 electrons next to it. Right now each fluorine only has 2 from the bond, so that means it needs 6 dots for each fluorine. Okay, so you add them all up. 8 around each one, 8 times 5 of them is 40, which is good to go. So you can practice some more of these examples, and we'll be doing plenty of practice in class.